Swayam Prabha. Digital India. Educated India.
Welcome once again to our discussion of qualitative response model, and yesterday we were discussing about the estimation part, right? We were using the statistical software to estimate the Logit and linear probability model that we were discussing. And what is the model we were estimating? We were basically estimating the model or where the dependent variable is married woman's labor force participation, whether a particular married woman will participate in the labor force or not, that is basically is a function of several factors, but we are considering only 4 factors: number of kids below 6 years of age, then husband's wage, education of the married woman, and then experience, if any, of the married woman. So, basically your dependent variable was in labor force, INLF, in labor force, which is equals to alpha plus beta 1 education plus beta 2 experience plus beta 3 number of kids less than 6 years of age plus beta 4, which is husband's wage, plus the error term. This was the model we were discussing, and what basically we were doing, we estimated the model. I will once again estimate the model. So, let us see how we can estimate this. So, this is basically what is the command for Logit model, Logit Logit, and then all your dependent variable in labor force, INLF, and then instead of typing the variable's name here, you can directly click here also, Stata will take, then you have to put education. If you click double click on the variable's name, then the variable will automatically appear here, education, and then kids LT6, and then husband's wage, okay, husband's wage, and if you put enter, then this is the model that you have estimated, which shows that this is the result. That means from this output, what we can say, whether there is positive or negative relationship between a particular variable, let us say education, and the labor force participation, which shows, for example, education variable which is 0.19, and it is highly significant also, which indicates that as education increases, probability of labor force participation also increases, but we cannot take this value as a marginal effect. That means we cannot say that for 1 unit change in education, what is the change in probability, because our dependent variable is basically log of pi by 1 minus pi. So, that means you can say that for a unit change in education, log odds ratio changes by 0.19, right. And then we say that you have to specifically put a command to estimate the marginal effect. And what is the marginal effect command we discussed? The command is very simple, MFX command, okay, marginal effect, which is if you put enter, then you will get the marginal effect, right. So, now you can say that for a unit change in education, your labor force participation changes by 0.04 unit. Now, we need to discuss little more on this marginal effect. First of all, when I am saying that for a unit change in education, your probability of participation, labor force participation of a married woman changes by 0.04 unit. That means whenever you want to measure a change, the change has to be made based on some reference point. If you do not know the reference, then the change concept does not make any sense, right. So, what is the reference point? That means you need to calculate a base probability based on which all these changes are actually calculated, and the base probability is calculated using the y value what data is showing. This y, this is actually your yi hat, that means you can say this is your pi hat equals to 0.57. Now, what is this probability? As you know that for any econometric models, whenever you are going to interpret the beta coefficient is always interpreted as a change. That means for a unit change in any explanatory variable or a percentage change in any explanatory variable, what is the change in your dependent variable, right? And for that change concept, as I told, that you must have a base point. For a standard regression model, what is that base point? That means you estimate the model, then you must calculate yi hat. And then when you say that when income changes from 1 unit, what is the base point? From that, from the point where, how will you calculate? That means when your model is yi equals to alpha plus beta xi, that means when income changes by 1 unit, your consumption changes by this much unit. And what is the reference point for consumption? That is actually yi hat. Okay. Similarly, in this context, when you are saying that pi equals to, let us say for Logit model, pi equals to 1 by 1 plus e to the power minus zi, this is your Logit model, okay, where zi is basically your alpha plus beta xi. So, once you estimate the model, then immediately you must calculate the pi hat. So, the change in probability is from this particular base point, which is pi hat, that you have to remember, and Stata is using this pi hat as this 0.5733, right. And also you have to also remember that all this change, all this interpretation for the coefficient is for an average individual. That means the MFX command, the marginal effect, please keep in mind that this is always for an average individual. Okay, for average individual. Why this is so? Because your marginal effect shows dpi dxi equals to equals to your beta hat, I will say beta I hat for beta hat into pi into 1 minus pi, and once you estimate, then all these are hat, okay, all these are hat. Now, why I am saying that marginal effect concept is only for the average individual? Because how will you calculate pi hat? To get pi hat, you must specify some xi, because from this model you will get alpha hat and beta hat. Once you know your alpha hat and beta hat, you must plug in some value for x to get your pi hat. And what value of x you will put? the average value of x. That means, this estimated probability pi hat is calculated as at sample mean. That means, when you have these variables education, experience, kids and husband's wage, this marginal concept is actually applicable to that particular married woman whose education level is at average, sample average, whose experience is at sample average, whose kids, number of kids are at sample average, and whose husband's wage is at sample average. That is why that particular married woman is called an average individual or a representative individual. That means this average individual, this is actually an imaginary concept, okay? Because in your data set, no one is having that level of education, right? Every individual is having her own level of education, own level of experience, kids and husband's wage. But interestingly, my marginal effect concept is related to only that average individual that may or may not exist, I don't know. It may so happen that by chance there is an individual whose number of kids is at sample average, education and all other factors is at sample average, which is quite unlikely. You may or may not get, but the interpretation is always only for average. That is applicable for the standard econometric model as well as in this case of qualitative response model. Okay. So, that means since pi depends on your xi and xi is basically all these independent variables, even though you are interested to calculate the marginal effect for let us say ith x1i, let us say this is x1i, it all depends on all other explanatory variables, okay, which is not the case in linear probability model, because in linear probability model what was happening, your pi equals to alpha plus beta xi. So, if you differentiate in linear probability model in LPM, what was happening, your pi is basically alpha plus beta xi. So, that means if you take this, it would be only only beta. So, that means it all, and what is beta? Beta is attached to only xi, but here it is pi and pi is based on all other explanatory variable. That is why while linear probability model marginal effect is calculated based on only that particular variable for which you are interested to calculate marginal effect. In the context of Logit model, it all depends on other factors as well, okay, other factors as well, because pi hat you have to calculate based on your beta 1 hat x1i plus beta 2 hat x2i, like that. That is one thing you have to, all other explanatory variables and their estimated coefficient. Now suppose I do not want that type of marginal effect, that means I do not want the marginal effect for the average or representative individual who is an imaginary person. Rather, I want to calculate the marginal effect for each and every individual, and then I can take the average of that marginal effects. Please try to understand what I am saying. In this context, when I am getting mfx command to get the marginal effect, this marginal effects data is calculating for the average individual. That means the representative married woman whose education, experience, number of kids and husband wage all are fixed at the sample average. Instead of doing that, I want to get another marginal effect concept. So, this is marginal effect concept 2, marginal effect for actual individual. That means marginal effect so that means if you have n number of individuals, you will calculate marginal effect for each and every individual. And then what you can do, Stata can run another routine for which you can get the marginal effect for each and every individual calculated and then get the average of that. So, when education changes for one unit, what is the change in probability for the first individual, for the second individual, for the third individual up to n number of individuals. And then I can calculate the average of all those marginal effect. That is also another marginal effect based on. So, that is basically average marginal effect. So, this is called average marginal effect. Average marginal effect. So, that means there are two marginal effects, marginal effect for the average individual and this is called average marginal effect. These are two different things. So, average marginal effect and earlier what we have calculated, that was marginal effect for marginal effect for average individual. Okay. So, this we have already calculated by MFX command, MFX. But this average marginal effect calculation requires a separate command which is called margef, M-A-R-G-E-F-F. So, after estimating the model, if you put margef command, so after estimating the model, let us say I will once again estimate the model. So, that means this is the model, okay, this is the model, Logit this and then I will put margef, M-A-R-G-E-F. Okay. This is called average marginal effect. This is slightly lower. See the marginal effect earlier model, this is 0.0429 and earlier it was 0.0487. So, little lower. So, average marginal effect is little lower than the marginal effect for the average individual. But you should know both these two types of marginal effect and you should also know in which way these two marginal effects are actually different. So, whenever you are estimating your model, this type of qualitative response model, please remember to report the marginal effects and both the two types of marginal effects and you should also interpret. In standard model, since the beta hat coefficients, they are direct measure of marginal effect, we do not need to mention anything else, but in Logit model, in qualitative response model, since beta coefficients are not a direct measure of marginal effect, we need to specifically mention or report the marginal effect, otherwise your research would be incomplete. Many a times after estimating this, we forget to report the marginal effects, but then your research would be incomplete, because at the end of the day what we are interested in specifically for the marginal effect. For a unit change in any of these explanatory variable, on an average what is the change in the probability of labor force participation, that is what we want, and that is why you need to specifically report these type of marginal effects, right. Now, once you are done with the marginal effects, then the other important things about the marginal concept. See here, when I am calculating marginal effect, then what you need to do, you need to specify the x values at the sample average, because you need to calculate pi hat. So, that means I am saying when number of kids changes by 1 unit, that means from that sample average to 1 unit change. So, that means I am calculating the probability of change for that woman who is having that many number of kids. But suppose my interest is little different, I want to calculate the change in probability of labor force participation for the married woman who does not have any kids, and then I want to see from 0 kid to 1 kid what is the change in probability of labor force participation, right. So, that means that also you can calculate. Suppose you estimate this Logit model, and then you can put this command mfx compute at kids LT 6 equals to 0, kids LT 6 equals to 0. Sorry, my command, I made a mistake here. mfx compute, we have to put a comma and then add kids LT 6 equals to 0. Now, look at what is happening. So, here Stata has calculated the marginal change assuming kids equals to 0. So, when the married woman does not have any kids, at that situation when education changes by 1 unit, what is the change in probability? When husband's wage changes by 1 unit, what is the change in probability? And when kids changes by 1 unit, this is very important. Now, see, from 0 kid to 1 kid, what is the change in probability? 0.32, right, 0.32. And what is the earlier one if you compare? Look at this, any earlier model, 0.3483, and here it is 3.32, okay, 32. It is a little different, 0.3483 and this is 0.32. Okay. So, from this model, once again you just see, this is your original model, this is the margep command and this is key. So, slight change in probability when you specify x equals to 0, right, when x equals to 0, this is 0.3483 and sorry, I forgot to mention the experience. Let me put experience also, Logit in labor force, and then I will put experience also, experience. This is the model, and then you calculate mfx, then this is 0.33, and now if you put mfx compute at mfx compute, what is the command I put? At in the bracket kids LT6 equals to 0. MFX compute, you have to end the bracket and then enter. Yeah. So that means when you have 0 keyed, then as you get the first keyed, your probability decreases by, probability of labor force participation decreases by 0.30, but when you have the average number of keys 0.23, it is 0.33. So that means lower reduction in the probability when you get the first key, and then it keep on increases. So which makes sense also. So it is quite difficult to manage more keys than when you have the first one. So that means you can calculate, you can specify a specific level of value for the x and calculate the marginal effect by this command mfx compute at kids equals to 0, and similarly you can also put education level equals to 0 or a specific value of education, husband's wage, so on and so forth, okay, based on your research interest. All right, these are all based your marginal effect, but when you estimate any econometric model like previous cases, you need to know how good is your model in terms of goodness of fit, right? That means R square, okay, R square.